So let us learn about the plane in 3D geometry. The equation of the plane passing through x1, y1, z1 and perpendicular to a line whose DRs are a comma b comma c. The characterization of the plane is that passes through some fixed point, its coordinates are given as x1, y1, z1 and perpendicular to a line means normal to that plane is given. So the normal to that plane is a straight line whose direction ratios are a comma b comma c is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This comes from r minus a dot b is equal to 0. So this is exactly the plane now. Suppose this plane passes through a x1, y1, z1 and this is a normal to this plane. Now, if I take a general point here P, whose coordinates are x comma y comma z, then A is there on the plane, P is also there on the plane, then line joining AP is also there on that plane. To that plane, this line is perpendicular. Therefore, AP will be perpendicular to this line. Means AP dot that line is 0. That is same as a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0 is the equation of the plane. So this is when we expand it, ax plus by plus cz minus ax1 minus by1 minus cz1, that is a linear equation in x, y, z. X term, y term, z term and constant term. This is the most general equation of a plane, that is ax plus by plus cz plus d is equal to 0. And in this one, this xyz coefficients a comma b comma c represents direction ratios of a normal to that plane. Always, students, you remember this, a comma b comma c represents, that is xyz coefficients represents direction ratios of a normal to that plane. Right, and this is obtained from the equation r minus a dot b is equal to 0. This is the plane passing through the point A, whose position vector is vector A and perpendicular to vector B. R means position vector of the general point, that is xi plus yj plus zk. When we substitute here, you will get that plane equation exactly like this. The equation of the plane passing through 2 points A, x1, y1, z1, B, x2, y2, z2 and parallel to a line whose DRs are a comma b comma c is obtained from, that is r minus a dot ab cross b. That is A is the point A, B is the point B. So vector AB is on that plane, means parallel to that plane. B is also parallel to that plane. Then AB cross B will be perpendicular to that plane. Therefore, this AB cross B will work as a normal to that plane, passing through A and perpendicular to AB cross B. Means in this equation, this role of B is played by AB cross B. That is same as in determinant form, R minus A. This is a scalar triple product of these three vectors. R minus A means x minus x1, y minus y1, z minus z1. AB means x2 minus x1, y2 minus y1, z2 minus z1. And vector B is that a comma b comma c. Expand it and equate it to be 0. This equation becomes a linear equation in x, y, z. This represents the plane passing through 2 points A and B and parallel to a line whose DRs are a comma b comma c. Equation of the plane passing through 3 points A, x1, y1, z1, B, x2, y2, z2, C, x3, y3, z3. That is passing through A parallel to AB cross AC. AB will be there on that line. AC also will be there on that line. Then AB cross AC will be a normal to that plane. That normal will be AB cross AC. So in that R minus A dot B equation, role of B is played by AB cross AC. That is passing through A, R minus A, X minus X1, Y minus Y1, Z minus Z1. Then AB, X2 minus X1, Y2 minus Y1, Z2 minus Z1. And AC, X3 minus X1, Y3 minus Y1, Z3 minus Z1. This determinant should be equal to the 0. When we expand it, we will get a linear equation in XYZ that exactly represents the plane passing through these 3 points A comma B comma C. This is obtained from R minus A dot AB cross AC is equal to 0. That is R minus A dot B minus A cross C minus A. Its scalar triple product is exactly this. The equation of the plane passing through A 0 0, 0 B 0, 0 0 C. That is exactly this case. That is passes through A 0 0 means its x-intercept is A, y-intercept is B, z-intercept is C. Or else this xyz intercepts are A comma B comma C is x by A plus y by B plus z by C is equal to 1. This can be obtained very easily from this equation. X minus A, this is x1, y1, z1. X minus A, y is z here, and B minus A, that is 0 minus A, that is minus A, B 0 here. Like that AC also minus A 0 C here. When we expand this determinant, you will get exactly this equation. It is also called intercept form of the plane. If you take a general plane, AX plus BY plus CZ plus D is equal to 0, this can be converted into intercept form. That is, take this constant other side, that is D is taken other side, AX plus BY plus CZ is equal to minus D. To get this one, divide with D. Then it happens that A by minus D times X, B by minus D times Y, plus C by minus D times Z is equal to 1. This can be written as X by minus D by A plus Y by minus D by B plus Z by minus D by C is equal to 1. Means for this plane equation, if you convert this into intercept form, its intercepts are x-intercept minus D by A, y-intercept minus D by B, z-intercept minus D by C we will get. So these are the intercepts of x, y, z.